Hello, and welcome to my YouTube channel. I will teach you statistics, mathematics, and daily Leetcode questions. Today we are going to do the question find the maximum sum of node values. Okay, this is a Leetcode Hard AF, but after this video it will only be hard. Okay, so let me tell you this. If you're not able to do this question on your own, don't be disheartened, because this is a it's not very intuitive. You have to really think how this question is stated and what will you do, to solve this. Okay, um, I'll tell you the question in brief what it is. So basically you're given a tree which is undirected. Okay, and basically you're given some nodes and edges. Okay, and you have to tell that if you do operations on these edges, right? So you're not doing operations just on a particular one node, you're doing it on a edge. Okay, so an edge contains two elements, right? So two nodes you have to do XOR, and after the XOR, what will be the maximum sum of all the nodes that you can achieve. Okay, I'll take an example here. So let's say this is the example. Okay, okay. um, so let's say that you're doing a XOR operation on this edge. Okay, so first you will do XOR of, and k will be given the element that you have to XOR on. So let's say k is given as 3. Okay, uh, so let's say that you are given k equal to 3, you do XOR on 1. So 1 XOR 3 will be what? So right here I will write all the after the XOR operation what will be the value. So this will be 2, this will be 1, and this will be 2, right? So after the XOR operations what will be the node values, right? And you have to select the edges in a way that it will give the maximum sum of all the nodes, right, in the end. Okay, how will you think about this question? Let me give an example. What is the problem here? That we have to do the XOR operation on a particular edge, right? That means if I change one value of the node, let's say I know that 1 will be changed to 2 and it will give the maximum, right? Because then 2, we can just select 2, right? What will be the problem? Because we will change 2 to 1 also, right? So then this value will be decreased and this value will increase, right? And one more thing that you can see is every time we select an edge, we are changing two nodes, right? Not only one nodes, two nodes. So the number of nodes changed in the end should be even, right? It should be even, right? So if we select this edge, it will be 2 1, and then let's say only 2 is there, so the sum will be what? 5. Okay, the problem is that every time we have to select an edge, we are decreasing some value and we are increasing some value, right? So we don't know particular for sure that what will be the maximum value of the node. That's why it's hard. Okay, it will be easy if we were given that, okay, every node is given and you just have to XOR and give the maximum of all the nodes, right? What will you do? You will select all the nodes that increases the value, right? You will select the values 1 comma 1, right? Why? And not 2? Because 2 XOR 3 is 1, which decreases, but 1 XOR 3 is 2, which increases, right? So if we are given that only you have to select nodes which after doing XOR you increase and then you give the answer, right? Then it will be easy, right? Okay, one more thing that you have to notice is we can select two nodes, right? And we increase the value of the total sum, but every node is connected, right? One is connected to one through this path. Okay, so if I select all the edges in this path, what will happen? Let's see. If I select this edge first, we do XOR, and then it will be 2 1, right? And then we select this edge, this 1 will become 2 again, and this will be 2, right? So the resultant will be 2 2 and 2, which will be 6, which will be our answer, right? What did you notice? That on the first operation, this 2 became 1 and then it changed to 2 again, right? So we know the XOR property that A XOR B, right? XOR B is A, right? Because B XOR B is basically nothing, right? You don't have to actually do anything, right? It will be 0, right? And A XOR 0 is A, okay? So let's keep this in mind, right? Now the approach is, we know that some nodes after XOR operation increases in value, right? So what if we just select these nodes in a way that we do not select those nodes that the value decreases such that the value decreases, okay? What is one way to do this? Let's just sort all the values, right? So our initial was 2 1 1 to 1. Let's sort this. Now we get 1 comma 1 comma 2, right? We know this value increases, so we just select these two because these are even, right? So we just do this 2 comma 2, and we know that there are no two other nodes. We always need two nodes, okay? Notice that we always need two because we need every edge means two nodes, so it should be even. So even will be this one, right? So first we select two nodes, then we cannot select this, we leave that because then it will be, this will become 1, right? And there are no, it will not be even, so our answer would be 6, right? So you notice that, let's say this was 1, this was 2, and this was 1, right? We notice that if we just select 1 and 1 in that path, every node in between that path is remaining the same after the operation, because after every two operations it becomes the same. After every two XORs it becomes the same, right? So let's keep this in mind, okay? So we know that every node can have two values. Either it can be original value or it can be XOR value, and this can be either greater than original or less than original, right? So two things we know: we can select any two nodes, and all the values in between will not change. So we can, like this, we can select all the nodes which increases the maximum, right? And then we don't have to take values which decreases after the XOR, right? Because then we are just penalizing our maximum value, right? Okay. So every XOR has two values, right? So for every node, we can either do XOR or not do XOR, right? This sounds like recursion, right? Every time we have a choice, we either do XOR or we do not do XOR, and then we take maximum. But the point is, it should always be even, right? So we take a value even, which says that till now the number of operations we have done is even, right? Let's say this is 1, right? So is even is equal to 1 means number of operations till now done are even, okay? So if we get the maximum value and the maximum value corresponds to this is even thing, that means that till now this will give the maximum answer, okay? Let me write the pseudocode for you, okay? You understand what I'm saying, right? If I have a path between nodes, let's say these values do not matter to me right now, these value increases, we select these and we do XOR on these two nodes, and we know that in that path all the values will remain same because after every two operations the XOR will be same, okay? So what will be our pseudocode? For basic recursion, our pseudocode will be, we define our XOR function, right? And we have two values in this. That node I, because we are given nums, right? The value as an array 1 2 1, and edges that we can leave, right? we are given that we are given taking that index of this nums, right, from starting to end, and we know that it should be even, right? So we take is even, which says that till now the number of operations done are even, right? And we only take those values, right? So we know that if it reaches the end, which is length of nums, and it is even, we return 0. Okay, but if it is not even, what will we do? What will we return? We want to maximize it, right? And we don't want where this is not even, so we will return the minimum of int, right? We will take the minimum such that, so that our maximum value is always for this is even thing. Okay, now if this thing, so first let's do XOR, right? So we are doing XOR I plus 1, and the other thing is we do not do XOR, right? So is even, right? And if we do XOR, then it will only contain the original value. This is our original value, right? But if we do not do XOR, so this is when we do not do XOR, right? This will be not XOR, this will be do XOR. Okay, if we do XOR, then even will be changed, right? And nums of I, we do a XOR operation on this, right? This operator does XOR, okay, for the given particular value. Okay, so we know this will be our basic recursion, right? And then we return our max of a comma b, right? And this is how we will know what is our result. Okay, now the problem is this will give a TLE. Okay, this will give a TLE because the total number of elements are very high. Okay, so what we have to do when we get TLE in recursion, we do dynamic programming, which is we can do memoization. Okay, so in this solution, how do you do memoization? Nothing, you just store this value d of I comma is even as max of a comma b, and then you return this d of I comma is even, right? That's how you convert every recursion into a dynamic programming solution, right? And here right, we say if I comma is even exists in our d, then we return our d I comma is even, right? And then our basic base solution, which was I equal to length and that thing, right? This is our base block. This is our memoization. This is our recursion, right? So now we will check the code, right? And I will show you how it is done in Python, right? Don't have to be scared about this question. It is hard, but after understanding how it works, it will be very easy. Okay, so first this will be our memoization, right? We initialize a dictionary. I use dictionary because it's easier to use. So we define our XOR function, and we know is even and I, the index, right? If it reaches the end of our recursion tree, so this is our leaf node, right? we check if it is even. If it's even, and if it is not even, right? So if it is not even, we return the minimum value, right? Now we do memoization here, right? So we say that if this index and when it is even is in D, we return that value. We do our basic recursion, right? I plus 1, this is when we are not doing XOR, right? We just simply add num's I value to our even, right? And this is when we are do XOR, right? And how will we know that we are doing XOR? Is even, and then we XOR it with 1, so this will become 0, right? And then this will become whatever the XOR value of that num's I is, okay? And then we store it, we store the maximum of these, right, into our memoization, and then we return that value. We start with 1, right, that it is even, right? So let's keep a dry run, okay? So let's say the first value comes, it will go here, we have not done anything, right? This will go here, right? Now if we do XOR, right, we do XOR only even number of times, so this will become 0, right? Now we have done only one XOR, so this will become 0, right? And as when this will come here, this value in this recursion, what will happen? This will be 0, and then when we do second element XOR, this will become 1 again, right? So this is how we keep track of how many number of elements we have done XOR on. So if it is even number of XORs, we have done 2, right? So first will be 1, then it will become 0, right? Even is 1, so we have even number of sets when we have not done anything, right? Because it's 0. Then we will do 1, if we XOR one element, it will become 0, right? That the number of elements we have done XOR on is not even. Then we do again on the second element, it will become, right? And we can select any 2 elements in that tree, because every node is connected to every other node, and thus there are a few elements in between. And if we do XOR on each of these edges, those elements will not change, only the last 2 elements will change in that tree, right? So if we do this, we will run this, okay, and then we submit. Yeah, there you go. Okay, don't check this Leetcode time, because this is based on your internet speed and Python and all. This is not the actual thing. In an interview, you need to understand how this approach works, and you have to explain it to them, right? So there are only 2-3 things that you have to explain so that the interview is satisfied with your approach. Okay, what is the brute force? Where we're not doing any memoization. We do memoization, dynamic programming, and then we will have our optimized solution.
もう死んでいる。何？もうあたくびできれぶ。